Imagine a star so immense, so unfathomably vast, that it could swallow not just our planet, but the entire inner solar system, stretching its fiery arms past Mars, and even brushing the edges of Jupiter's orbit. Its sheer scale defies comprehension, making our sun look like a mere spark in comparison. This isn't the stuff of science fiction or distant myth. This is the astonishing reality of a red supergiant star, caught in the final breathtaking moments of its existence. These cosmic titans are among the largest and most luminous stars ever to exist, and their endings are as dramatic as their lives. As the star nears its end, it sheds its outer layers in colossal, shimmering waves, casting vast clouds of gas and dust into the void. In this violent process, it forges the very elements that will one day become the building blocks of planets, oceans, and even life itself. Deep within, the star's core is running out of fuel. With nothing left to burn, gravity takes over, pulling the core inward with unstoppable force, triggering a dramatic collapse that marks the beginning of the end. What we're witnessing is the universe's grandest recycling act, a cosmic transformation where death gives rise to new beginnings, and destruction paves the way for creation. Once a stable beacon in the night, this red supergiant now burns heavier and heavier elements in a desperate struggle against gravity's crushing grip. Each fusion reaction is a last stand, a final attempt to stave off the inevitable collapse. Its surface is a churning, boiling sea of plasma, glowing a deep, menacing red. Massive convection cells rise and fall, creating storms larger than entire planets. The light we see from these distant giants began its journey centuries ago. Each photon a time capsule, a message from a past era, crossing the vastness of space to reach our eyes tonight. The iron in your blood, the calcium in your bones, the carbon in every living thing, all were born in the heart of stars like this. Every atom heavier than hydrogen and helium was forged in the crucible of stellar death. When you gaze up at the night sky, you're witnessing a universe in constant motion. Stars being born in glowing nurseries, others dying in brilliant cataclysmic displays, each one shaping the cosmos in its own way. Each star is a chapter in the endless cosmic story, a unique tale of birth, life, and transformation, written across billions of years. The death of a star is not a final curtain, but a transition. Its remnants seeding the galaxy, fueling the next act in the universe's grand drama, and ensuring that the cycle of creation continues. This is cosmic recycling on a scale that dwarfs anything we can imagine. Gas and dust flowing between stars, galaxies, and nebulae, weaving the fabric of the universe itself. We are, quite literally, the children of dying stars. The atoms in our bodies were forged in ancient supergiants, connecting us to the cosmos in the most profound way possible. The universe's greatest show is also its greatest gift, a reminder that from the ashes of cosmic giants, new wonders are always waiting to be born.
Deep inside a dying giant, gravity and fusion wage their final war. This cosmic battle has been ongoing for millions of years, a testament to the star's resilience and the forces that govern the universe. For eons, fusion's outward push balanced gravity's inward pull. This delicate dance kept the star stable, a beacon of light in the vastness of space. But now, the hydrogen is gone. Gravity starts to win, compressing the core and raising its temperature. The star's core becomes a cauldron of intense heat and pressure, a crucible for new elements. A shell of hydrogen ignites around the core, swelling the star to hundreds of times its original size. This expansion is both majestic and ominous, signaling the star's transformation into a red giant. The star becomes a red giant, unstable and immense. Its surface roils with turbulence, a reflection of the chaos within. Helium fusion begins, creating carbon in a process called the triple alpha reaction. This process is a vital step in the cosmic cycle, forging the building blocks of life. The star finds a brief, volatile balance, but it's short-lived. This fleeting stability is a mere pause before the next phase of its life. Layers of fusion form, like a cosmic onion, each shell burning a different element. This intricate structure is a testament to the star's complexity and the processes that drive its evolution. The star pulsates, expanding and contracting like a cosmic heart. Each pulse is a powerful reminder of the star's vitality, even in its twilight. With each pulse, it sheds more of its atmosphere into space, a wind rich with new elements. This stellar wind is a gift to the cosmos, seeding the galaxy with the ingredients for new stars and planets. The star is dismantling itself, piece by piece. This gradual disintegration is a poignant reminder of the impermanence of even the most massive celestial bodies. This is the heartbeat of a dying star, a slow, powerful rhythm marking its final days. Each beat echoes through the cosmos, a testament to the star's enduring influence. Each pulse shapes the future of the galaxy. The star's legacy is woven into the fabric of the universe, influencing the formation of new celestial bodies. The end is inevitable, but the legacy is eternal. The star's remnants will continue to illuminate the cosmos, a lasting tribute to its once glorious existence. Meet CW Leonis, the closest carbon star to Earth, hidden like a cosmic jewel in the heart of Leo's constellation. Though it sits just 400 light-years away, it remains a mysterious presence in our night sky. Invisible to the naked eye, CW Leonis blazes with intensity in the infrared spectrum, its true brilliance revealed only through special telescopes. It is shrouded by thick clouds of carbon-rich dust, making it nearly impossible to spot in visible light. CW Leonis is what astronomers call a carbon star. Its atmosphere contains more carbon than oxygen, a rare and fascinating stellar chemistry. This surplus carbon doesn't just float away, it bonds into complex molecules and forms cosmic soot, creating a thick, dark veil that cloaks the star in near-total darkness. Powerful pulsations from the star's core lift carbon-rich gas outward, where it cools as it drifts away and condenses into tiny grains of dust, slowly building up the star's dusty shroud. In this way, the star becomes both the creator and the prisoner of its own dusty cocoon, its light trapped within the very material it produces. Once, CW Leonis was a stable, ordinary star. Over millions of years it evolved, dredging up carbon from deep within its core and carrying it to the surface in a dramatic transformation. This process turned it from a typical red giant into a carbon-shrouded marvel, a star transformed by its own internal alchemy. The chemistry of CW Leonis is unique in the cosmos, and its fate is nothing short of spectacular as it continues to change and evolve. The star's own ashes, its carbon dust, hide its brilliance from our eyes. But in the infrared, it shines as a beacon, a hidden giant revealed. CW Leonis is a living laboratory of stellar evolution, offering astronomers a rare glimpse into the life and death of stars. Its story is one of constant transformation and self-creation, a cosmic cycle of birth, change, and eventual demise. In its death, CW Leonis sows the seeds for new worlds, enriching the galaxy with the building blocks for future stars, planets, and perhaps even life itself. CW Leonis pulses every 649 days, swelling and shrinking in a cosmic rhythm. Its surface churns with convection, driven by the energy from its unstable core. Each pulsation dims its visible light but brightens its infrared glow. The star is no longer stable, it's in constant flux, teetering on collapse. With every pulse, it loses more mass, creating a dense, slow wind of gas and dust. This wind carries away the star's outer layers at an astonishing rate. The ejected material forms shells and arcs, cosmic rings, marking each pulse. By studying these structures, astronomers read the star's history. Each shell is a record of past upheaval. The star's final breaths sculpt its surroundings. CW Leonis is dismantling itself, leaving a legacy written in dust. Its death is a creative act, shaping the future of its cosmic neighborhood. The material shed by CW Leonis forms a vast, complex circumstellar nebula. Opaque in visible light, it glows in infrared, a treasure trove for astrochemists. This nebula is a chemical factory, rich in carbon and organic molecules. Over 50 molecules have been detected, from simple CO to complex carbon chains and even water. The nebula's shells and arcs are cosmic ripples, each marking a major ejection. By measuring these, astronomers reconstruct the star's final millennia. The nebula will eventually dissipate, but its elements will seed new stars and planets. The legacy of CW Leonis will endure in the next generation of worlds. Stardust from this dying giant may one day become part of new life. The cycle of creation continues, fueled by the ashes of dying stars. What happens to the planets of a dying star like CW Leonis? Inner worlds are doomed, engulfed, vaporized, or stripped bare as the star expands. Outer planets might survive, but face intense radiation and destabilized orbits. There may even be a surviving companion, shaping the nebula's structure. Detecting such survivors is difficult, hidden by dust and glare. The fate of these worlds is a reminder. Solar systems are temporary, reclaimed by their stars. The cosmic dance of creation and destruction spares nothing, not even planets. The mass-losing phase ends, fusion flickers out. The core collapses, halted only by electron degeneracy pressure, a quantum effect. The star becomes a white dwarf, Earth-sized, incredibly dense and blazing hot. Its ultraviolet light illuminates the ejected gas, creating a planetary nebula, a glowing, short-lived shroud. The nebula's shapes are sculpted by the star's past and any companions. Planetary nebula is a misnomer. These are the illuminated ghosts of dying stars. This phase lasts only tens of thousands of years. As the nebula fades, only the white dwarf remains. The star's final act is to light up its own funeral. What's left is a stellar ember, cooling in the dark. The white dwarf cools slowly, radiating its stored heat for billions of years. It fades from blue-white to red, then to darkness, a process longer than the universe's current age. No white dwarf has yet cooled to a black dwarf. They are theoretical, awaiting the far future. These stellar remnants are the quiet ghosts of once brilliant stars. Eventually, the white dwarf will become a cold, dark ball of crystallized carbon and oxygen, a stellar diamond. The universe is young. Black dwarfs are its distant future. The story of C.W. Leonis is a reminder. Even stars are not eternal. The cosmos ages, and so do its brightest lights. Time claims all, even the stars. The journey of C.W. Leonis is the universe's story, a cycle of birth, death, and renewal. Elements forged in its heart now seed the galaxy, fueling new stars and planets. This is cosmic recycling, stardust drifting, gathering, and igniting new worlds. The carbon in our bodies was born in stars like C.W. Leonis. We are made of stardust, the legacy of dying giants. The death of stars enables life. Their ashes become the building blocks of the future. As we ponder the fate of distant giants, we reflect on our own origins. The universe is alive with transformation, and we are part of its grand lineage. The death of C.W. Leonis is a beautiful sacrifice, ensuring the cosmic story continues. We are privileged to witness and be part of this eternal cycle.